Hello everyone and welcome back to our channel. Today we are going to delve into a powerful technique for analyzing categorical data, cross-tab analysis. Cross-tab is one of the most useful tools in Pandas for analyzing tabular data is cross-tab function. This function allows you to compute a frequency table of two or more variables which summarizes the distribution of values in the data and provides insights into the relationships between the variables. Tabulation is an important tool for analyzing two categorical variables in a dataset. It is a statistical method used to examine the relationship between two or more categorical variables. It helps us understand how different categories of one variable are distributed across categories of another. By creating a contingency table, we can visualize how the frequency or proportion of observations in one category varies across different categories of the other variable. It provides a tabular summary of the frequency distribution of two variables, allowing us to see the relationship between them and identify any patterns or trends. By the end of this video, you will be able to create and interpret cross tables, gaining valuable insights into the relationship between categorical variables in your data. After removing unnecessary data, we apply some methods on the dataset. One of that is cross-tab methods. So we know what is cross-tab analysis and why it is used. First, what is cross-tab analysis? A simple and powerful technique to analyze the relationship between two categorical variables. It creates a frequency table of each combination of categories. Why use cross-tab analysis? Understand the distribution of categorical variables, identify patterns or association between variables, search for which are the parameters are applied on cross-tab. There are some parameters like index, columns, row names, call names, egg function, margins, margin names, and drop NA. There are some arguments which are applied on cross-tab. Breakdown of common parameters like index. Index specifies the row labels of the cross tabs. Columns. It specifies the column labels of the cross tab. Margins includes row and column total in the cross tab. Normalize. Normalizes the value in the cross tab. Option include index, columns, all. Drop NA. Drop NA drops row or columns containing missing values. We have multiple variables in our data frame, and if you want to understand the data more, you basically want to check the relationship that exists between the variables. For example, we can check the relationship between any categorical variables using cross tabulation, or if you want to do unvariate analysis on a categorical variable, you can also create a frequency table so that you will know what is the frequency of each categorical that are available under a variable. Now let us see how to create a frequency table. So crosstab is the function that comes from the Pandas library, which is used to compute a simple cross tabulation using one, two or more variable. By default, it creates a frequency table of the factors. So now let us see how to create a frequency table. So I have used a pd dot cross tab, that is the function that is used to create a frequency table, and as an input to function I have used it as index, transmission time, type, columns count, and remove the unnecessary data using drop NA. Index is transmission time. There are automated manual, automatic, direct drive, manual or unknown, and count, which count the how many cars are automated, manual, automatic, direct drive, manual or unknown. So in the previous example we have considered only one categorical variable just to get the frequency distribution of each categories. Now we can also have one more variable to check the relationship between those two categorical variables. If you want to check the relationship between two categorical variables, you can go for two-way tables. And here we are going to use the same function to create a two-way table, and in this example we are going to look at the frequency distribution of car model with respect to different type of transmission type of the car. In the previous example you have just looked at frequency distribution of transmission type, but here we going to look at frequency distribution of model with respect to the different transmission type of the car. So let us see how to do that. We are now print DF4. Here we see two-way table between transmission type and engine cylinders. This is a two-way table of the data. The two-way table gives the output in terms of numbers. There is also a way where you can convert the table values in terms of proportion, and that is what we mean by joint probability. By converting the table values from number to proportion, you will get a joint probability values. You will get the joint probability values, that is also using the same function cross tab. Let's see how to do that. Probability, we add one parameter, normalize, equal to true. Code run successfully. Print df file. Here joint probability between transmission type and engine cylinder are given as output. If you set normalize is equal to true, you are basically converting all the table values from numbers to proportion. That is what normalize means. Now we going to look at how to get the marginal probability using the two-way table. We are going to use a same function, but just tweaking or by just adding one more parameters, we will be able to arrive at different types of probability values. So here we are going to look at marginal probability. So marginal probability is the probability of the occurrence of the single event. It will consider by the occurrence of a single event. So here is the code for that. We add one parameter, margins equal to true. So here index and columns parameter remains the same, and we have used drop na is equal to true and normalize is equal to true because we want to all the table values in terms of proportion or the probability values. And I have also set margins is equal to true in order to get the marginal probability value. By setting margin is equal to true, you are basically going to get the row sums and the column sums for your table values. Let us see the output. So here is the output. In the previous example you would have got till here you didn't get the row sum and the column sums of it, but by setting margins is equal to true you will get row sums, the last numbers of rows. All column is represent the row sums, and here all presents for the column sums. What is we mean by marginal probability? The highlighted values are nothing but the marginal probability values. And how do these values. Now let us move on to get the conditional probability using the two-way table. So here also we are going to use a same function, that is pandas cross tab, and let us see what conditional probability is about. So conditional probability is the probability of an event A given that another event B has already occurred. For example, if you want to get the probability of an event A by considering another event has already occurred, then you call it as a conditional probability. And now what is the example that we are going to look using conditional probability is that given the type of engine cylinders, what is the probability of different transmission type. So let us see how to get that. You see here the first four parameters remain the same. We have just tweaked the normalized parameter. Initially said that as true, but we have changing it into index just to get the conditional probability values. So now we are going to look at the output of, if you sum the row wise, then you get the answer 1 for all the rows, and it get the probability when automated and is already and with respect 0 0 engine cylinders, and for the further all the values we change the normalize as columns and check the output. Here now sum of all the columns is 1, and here all the row sums are 1. Now we are going to look at correlation, because till now we have been looking at to check the relationship between two categorical variables using cross tabulation. We are going to look at how to check the relationship between two numerical variables used to the measure called correlation. And what is correlation? Correlation is just to check the strength of association between two numerical variables, and it need not be always numerical variables, but in this case or in this lecture we are going to look at correlation of numerical variable. Theoretically or numerically, if you want to interpret from the correlation measure, then the correlation values bounded between -1 and +1. 0 represents there is no correlation at all between any two numerical variables, and closer to 1 represents there is a strong correlation between two variables. We are going to see how to get the correlation using Python. Core CORR is the function that is used to calculate correlation between any variables that you can use that for a data frame, because by using the core function we are going to compute the pairwise correlation of columns by excluding all the null values here, because we are not just going to consider only two variables, rather we are going to consider all the variables at a time, and the function computes the pairwise correlation. We will see what pairwise correlation is when we get the output, but this function is used to get the pairwise correlation of columns, and by default it excludes all the missing values from the data frame, and then it calculates the correlation value. And the method I have specified here is Pearson, because by default it calculates Pearson correlation, and Pearson correlation is also used for to check the strength of association between two numerical variables. If you have ordinal variables, then you can go for other measures as candle rank correlation and spearman rank correlation. So in that case We need to exclude the categorical variables to find the Pearson correlation. Now let us see how to exclude those variables which are of categorical data type. Here I remove object data type variable. Now see, we are exclude the object data type. So write in bracket exclude and give the object. So num underscore where takes only integer variable from our dataset. The code calculates the correlationship between different numerical variables in a dataset. This helps us understand how these variables are related to each other. For example, a high positive correlation between engine horsepower and highway MPG might suggest that cars with more horsepower tend to have better fuel efficiency on highways. On the other hand, a negative correlation between number of doors and popularity could indicate that cars with fewer doors might be less popular. By analyzing this correlation, we can gain insights into the relationship between different car attributes and potentially identify trends or patterns that might be useful for further analysis or decision making. Thank you for joining me on this journey through cross-tab analysis in Python. I hope you learned something new and gained a better understanding of how to use this powerful technique to analyze categorical data. Remember, cross-tab analysis is just one tool in your data science toolkit. By combining it with other techniques like data cleaning, visualization, and statistical analysis, you can gain valuable insights from your data and make informed decisions. If you have any questions or comments, please feel free to leave them below. I had also loved to hear about your experiences using cross-tab analysis in your own work. Don't forget to subscribe to our channel for more data science tutorials and insights. And be sure to check out our other videos on various topics including data cleaning, visualization, machine learning, and more.